Okay, welcome back. We're looking at number 12. We've got numbers between 5,000 and 6,000, and we've got 6 numbers that we can use, and we can not repeat them. So let's make spaces for our 4 numbers. There's only one number that can go in the first digit of 5. So then the rest of them I have 5 choices, 4 choices, and 3 choices. So that's 60 or 5 permutation 3, which is also 60. Now in part B, if I'm allowed to repeat, well still, I'm only allowed to use 1, 5 in that first spot. But the difference is, I can use 6s in the other ones, and 6 to the 3rd power is 216. And then the second part A, we're doing a choose 5 people from 6 boys and 8 girls. And the criteria is there has to be more boys than girls on the team. So the first way that's going to happen is if there's 8, choose 3, and then we can just fill in the boys. Or we could have 4 girls and then fill in the boys, or 5 girls and fill in the boys. Those are the 3 ways that we can have groups of 5 where there was more girls than boys. All you do then is do the computation and add them up. You get 1,316 ways. Now, keep in mind what they love to do is they love to make these into probability questions also. Right now, I've got the number of ways to have more girls than boys on a committee. All I've got to do is divide that by the number of ways to choose 5 people out of 14 people, which is going to end up being 0.657. Now, they didn't ask this question, but I'm just throwing this in. That's extra. All right, so 2B. Now I've got 3 cousins, which reduces my boys to 3 boys and 8 girls. And what they want to know is how many committees of 5 if the cousins are all on or all off. Well, if I'm choosing all 3 cousins, that's 3 choose 3. So then that leaves me with the possibility of 2 boys and 0 girls, and then I can keep on going down until I find all the different combinations. 1 boy and 1 girl, 0 boy and 2 girls. Those are the only ways it can happen if the cousins are all on. If the cousins are all off, there's a few more possibilities. I could choose all 3 boys and then 2 girls. I could choose just 2 boys and then I have to choose 3 girls. I could choose 1 boy and then that's going to be 4 girls. And then I could choose 0 boys and that's going to be 5 girls. Now, those are the only ways that I can do it. Now, I know it looks like a lot, but keep in mind, 3 combination 3 is equal to 1. 3 combination 0 is equal to 1. 3 combination 1 is equal to 3. A lot of these you can do without typing them in your calculator. For example, the first one is just 1 times 1 times 3. And then you see the 3, this is going to be 3 times 8. And then here, that's a 1, that's a 1. So I'm really just going to put in 8 combination 2 and find out it's 28. That's a 1, that's a 1, so then 8 combination 2 again is 28. I got a 1, I'm going to do 3 combination 2 times 8 combination 3, and that's going to be 168. That's a 1, that's a 3, 3 times 8 combination 4 is 210, and that's a 1, and 8 combination 5 is 56. Then I add up all those ways, and it's 517 ways. And once again, if it was a probability question and they wanted to know the probability of the cousins being on, or all off, I would take 517 and divide it by 14, choose 5. All right, but again, they didn't really ask that. I'm just throwing that in. All right, thanks for watching. Hope that helped.